Hello, we're going to finish this up today, so let's get started on number 43. 43, we have a numerator and a denominator. The nice thing about this is the denominator is a perfect square, so we won't have to rationalize the denominator. Okay, and I'm going to write the numerator as perfect squares. 16 times 5 is 80, and times w squared times w gets me the perfect square of w cubed out, and still with the other part that's not a perfect square. So when there's an odd exponent, you always have to take the next lowest even exponent and then the w to the first power. And that's also over 9. So then I'm going to take every perfect square out. So I'm going to start with the numerator first. The square root of 16 is 4. The square root of w squared is w. And that leaves me with 5w that don't get to come out and play. All right, and the bottom number is a perfect square. It is 3. Nothing to reduce here, so I'm done with that problem. All right. So we have a distributive property problem here with radicals. Okay, and I'm actually going to kind of show you a way that I handle these to make them a little easier. Okay. All right, so I'm going to distribute, and in the first one, I'm going to make that actually 10 times 15, and then I'll distribute to the next one 8 square roots of 10. Okay, and 15 is well, 10 is 5 times 2, and 15 is 5 times 3. Okay, and that means there's a perfect square of 5 in there, so, or 25. So I'm going to take a 5 out and leave the 6 in. All right, and then plus 8 square roots of 10 doesn't simplify. That is my answer. All right, another way to look at that one is 10 times 15 is the square root of 150, and 25 times 6 is 150. The square root of 25 is 5. 6 stays in. Okay. 45 and 46 are pretty straightforward. If I have 4 square roots of 3, and I add 3 square roots of 3, I have 7 square roots of 3, and that's the answer for that one. Same type of problem for 46. If I have 5 square roots of 10 and add 1 more square root of 10, I have 6 square roots of 10. Nothing left. There's no perfect squares hidden inside 10, so I'm done with that one. Okay. Solving a radical equation, the first thing you have to do is isolate the radical sign, which in this case it's already by itself. The whole expression is under the radical on the left side, so I can square it right away. So I squared both sides to get rid of the radical. Now I'm going to subtract 5 from both sides, and x equals 36. That is my answer there. All right, a couple more. 48, radical on both sides. Both the radicals are isolated, so we can square both sides of the equation just like we did in the first. That leaves me with 12x plus 1 equals 10x plus 7. However you want to solve that, I would subtract 10x from both sides. That leaves me with 2x plus 1 equals 7. I would then subtract 1. 2x equals 6. And when I divide by 2, x equals 3 is the answer. All right, so last 2 problems here. In this problem, we have to rationalize the denominator. I'm going to multiply the top and bottom of this expression by the square root of 21. That leaves me with 5 times the square root of 21 over the square root of 21 times the square root of 21 is actually just 21, because 21 times 21 is a perfect square. When I take the square root of it, I get 21. That is the answer. And always check, 5 and 21 don't reduce, so there's nothing else we can do. And this last one, solve using square roots. Again, there's no b value, so we can just move that away from the x. What is that, 7? And then we can divide both sides by 7. And that equals, sorry. And then I can square root both sides. And that gives me x equals plus or minus 1. The square root of 1 is 1. And there's my answer. I hope this helps you guys on your final exam. Good luck the next 2 days. And I'll see you tomorrow.